83 of your interactive notebook. Call it Applications of Exponential Functions. And so we're going to start with some formulas before we do word problems. And so applications just basically it translates into us doing word problems. And so the first sentence says all exponential functions have the general format of. And so this is your same exponential function that we've been using. B to the t is the parent function. This timesing by a is going to vertically stretch it or compress it, depending upon what's happening in the actual word problem. And so as far as what the values mean in the word problem itself, A will be representative of the initial value, how much you start out with, whether it's money or population. B is what's called the growth factor. If this was being doubled, B would be 2. If this was being, the population was going in half every year, this number would be 1/2. So that's going to be your growth factor. C is the number of time periods. I don't even know where C came from because I don't have a C. Must be T here, not C. T is your time that you're going to be dealing with. I'm not sure why I wrote C there. How silly of me. And then F of T is going to be the amount of the item after T time has passed. Yeah, so that's supposed to be a T right there. I don't even know where that came from. Sorry. All right, so we have a more specific formula when we're compounding money. These three formulas, or these two formulas that I'm getting ready to give you right now, are only used for compounding money. They cannot be used for other things besides compounding money in this first one right here, okay? And then the new formula that we have is A is equal to P parentheses 1 plus R divided by N raised to the NT. So in this case, capital A is still going to represent the total amount of money that we have. P is going to represent your principal, your initial amount still. And then this 1 plus R divided by N is going to be the exponential part, that is your base. And so this number is either going to be bigger than 1. Well, in this case, since it's compounding money, we're going to be a number bigger than 1, so that we're going to have increase. And so this R is going to represent your rate. N is going to be the number of times you compound per year. So for example, if the problem says you're compounding monthly, N will be 12. However, if you're compounding yearly, N will be equal to 1. This second formula is only used for compounding when you are, the problem states that it's compounding continuously. This is the formula that you will use instead of the one above. And so the only difference here is that this 1 plus R to the over N becomes E instead. Remember, E is approximately 2.71. And then your R, your rate, is going to be up here, and then your time as well. Okay? When you put in your rate, don't use the decimal form. Make sure to use the decimal form. And then two general formulas for exponential growth or exponential decay. This looks very much like your compounding money formula, which is this one right here. If N, which means that you're compounding, or if your N is equal to 1, which means you're compounding only 1 time per year, you'll notice that actually becomes the exact same thing as this formula right here, where N is equal to 1. So if you have N equal to 1, where you're compounding every year, then you have this formula, P parentheses 1 plus R to the T. If your 1 plus R, which is the base of your exponential, is bigger than 1, you're going to have exponential growth. And if you have 1 minus R, where this becomes less than 1, it's a number between 0 and 1 when you subtract, you're going to have exponential decay, and it's going to be a decreasing function instead. We're going to use some examples on page 84, but it is all for this page.